I don't know why. This is like one of my favorite assignments, and it's removable discontinuities, which is my favorite kind of discontinuity. Yes, you should all have your own favorite discontinuity. Mine is removable. So the goal here is we're going to figure out what value of k, and this always pops up on AP. We're going to find the value of k that is going to take what would be a removable discontinuity and fill it in. So notice this format of the piecewise. The way this is designed, this is saying that we have this function for every value except for -2. So the graph of this is going to be some line, but at -2, it's being removed. This right here is removing it. It's taking that point away, and then we're going to stick a different point when x is -2. So that point could be right here. So once again, this is the graph, x squared minus 4 over x plus 2. It's the graph for all values except when x is -2. So it's just going to be this nice line except for that one spot. And at that particular spot, the point is placed elsewhere. So we're going to figure out what value of k makes it continuous. In other words, we're going to try to figure out a value that puts this point right there, making it a continuous graph. All right, so how are we going to do this? I'm going to go ahead and figure out what would the limit be for this. What is the limit? Because remember, in order for something to be continuous, the limit has to actually equal the function there, right? So f of -2 right now, we know is k. So we got to figure out what that k value is. Let's figure out what the limit is, and then that's what our function is going to have to equal. So the limit as x approaches -2. We're going to be using this, because this is, remember, limit's not what it actually equals, which is right here. It's what it's approaching. So this is everywhere except that spot. You can see it on the graph. It's everywhere except that spot. So we're going to use this for our limit. So I need to factor the top, and I'm going to cancel. Substitute the value in. And I get that the limit is -4. So that means that the function will also need to equal -4. In order for this point to be here, this point has to be -4. So that's the idea there. That's all you're going to be doing. If you try this one out, we're going to be doing the limit as x approaches 0. So let's go ahead and factor the x out of the bottom. Cancel it out. Plug it in. And I get that the limit is 5. So that means that the function will need to equal 5 in order for it to be continuous. That way the limit, what it's approaching, will be the same as the function. In other words, we're going to take that point and drag it down to right there, or up, depending upon wherever that point is